Welcome to the Omar Alayli podcast, your go-to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Alayli, and today I'm thrilled to be joined by Adam Kall, the co-founder and director of science at Kahl-Morris Incorporated. Kahl-Morris aims to be the first company with a commercially viable product for collecting debris in orbit. Adam, thank you for joining us here today.
Thank you for having me. Excited to be on.
Adam, you have a degree in computer science and a master's in data science. And right after your master's degree in 2020, you co founded Kall Morris Incorporated. Can you briefly share with us your journey? What experiences and decisions led you to founding KMI and dedicating your career to space technologies?
Absolutely. The first pivotal moment I distinctly remember was junior year of high school, actually, sitting in physics class, learning the segment with friction involved, and thinking, wow, this is really annoying. I don't like dealing with the friction variable. I'm going to go work in space where there is no friction. I'm going to make it simpler that way. Little would I know how complicated that makes the physics, but that was the initial push of saying, I think I want to work in space. And I remember that so clearly. Several years later, I ended up at Northern Michigan University. And my sophomore year, I wanted to have an internship at NASA. I wanted to experience working in the aerospace field. And I remember asking around to my professors, and they said, we haven't had a student do that before. We're not sure of the process. And so I said, okay, I'll figure it out. And I'm happy to say that after I successfully received that internship, and after me, several other students then received internships in the summers following. So kind of started the chain there. But that summer was also pivotal because I learned that the public sector is very different than how I imagined it working in space. So it kind of set in this motion. I want to still work in space, but it's going to have to be through the private sector. And then that final key moment was in 2020 when me and my two friends from college were talking about, okay, we had our jobs, we wanted to move into aerospace, and looking around and not quite finding a company that fit our ideals and what we wanted to do. And so saying, okay, can we start our own? Can we make that formation of the place we want to work ourselves?
Great. Interesting. Were there any specific challenges or moments early in your career that shaped your view on the importance of on orbit servicing and logistics?
Yes, we started the process with the focus on space debris removal. That was kind of the motivating factor because we realized it was a significant problem. Early on, we discovered there's websites like spacetrack.org that publish conjunction warnings where they say these two objects are getting close, there's this probability of collision, and they post them as they come in. And watching those websites early in the process of the company, we had things to do, but it wasn't always a full day. And so sometimes I was going into that data set and analyzing it using my degrees to look and try to understand, and just realizing how widespread this problem was, but also it wasn't uniform. Something
Mhm.
early on that we heard from everyone is, tragedy of the commons. All debris is a problem to everyone. And that statement sounds nice. It's an easy soundbite, but it really seemed to brush over the complication of all these orbits are different, they cross each other. And it started the journey of realizing not all debris is everyone's problem. There's a normal distribution, and some debris is just a few people's problem. And that started the realization of there actually is a business case here. There's a business case for cleaning up all of space, this wider, global endeavor, but there's also a business case at the very beginning for specific customers that need that help.
Okay. Um, in your own words, how do you define on orbit servicing and logistics for those of us new to the field? And why is it becoming so critical for space operations today?
So that's a great question. And I need to call back to a little bit of American history. In America, when the colonies started expanding westward, there was this big cultural aspect of independence. You would go into the frontier, you would build a log cabin, and you had to do everything yourself. You were farming, you were chopping your own firewood, you were making your own clothes. Absolutely everything was your responsibility. And then as infrastructure followed, suddenly you could, get a stove or get a service or get some other external support that made your life a little bit easier. That same journey is now happening in space. For most of the space industry, we've been launching satellites that have to do absolutely everything themselves. They have to know where they're located, they have to maneuver around, generate their own power, communicate. All of it is the responsibility of this one box that you launched into space. With the advent of GPS, that was the first real servicing in my mind, because suddenly the satellite didn't need to know its position by determining all of this complicated math. It just needed a GPS receiver and it knows where it's at. That increased the efficiency of the mission, increased the safety of the mission, and lowered costs. We are looking at the next kind of servicing, which is end of life service. Rather than the satellite be responsible for how it deals with the end of life and how it deals for the time after its mission is complete, KMI can be that third party servicer that handles all that. The complicated logistics, the complicated regulations, we take care of that. And the satellite is able to, again, shrink and focus on what it needs to do to make revenue and complete the mission. So that, in my mind, is what servicing encompasses, is allowing these machines to focus on their task more clearly.
Okay, so KMI is developing a suite of services, like you just said, end of life services, orbit change maneuvers, and active debris removal. Could you explain how each service works and what unique challenges they address in space sustainability? Let's start with end of life services.
Absolutely. And so KMI as a company, we are not trying to do three entirely separate things. We are focusing on our core technology of grappling an object that is not able to move itself. As it turns out, though, there are multiple classes of those objects. So for this example of mission extension or end of life servicing, this is the idea of your satellite needs a plan for how it's going to end its mission, but that plan has to be enacted while the satellite is still functioning. So if your plan is, oh, I'm going to, push it to a graveyard orbit or deorbit my satellite, those plans occurring while the satellite is still functioning means you're cutting off revenue. You're cutting off service that could continue because of the risk of failure. By having KMI on standby and on contract, you can keep operating your satellite. You can continue to have it generate revenue, provide service, do the critical functions that it was designed to do. And when it does fail in the orbit it was in a state that is not ideal, we come in and service it and move it out of the way. So we achieve life extension not by clamping on and powering its orbit and moving it around directly, but by providing that confidence that the end of its mission will be handled.
And you're providing that service through a graft, right?
A spacecraft, yes, with a universal grappler on the end. So that's the core technology of KMI, is the ability to grapple with an object that wasn't prepared for it. Like I said, we started with space debris as kind of our target, which of course is not prepared and is really kind of a bad dance partner when it comes to docking. And so this same technology can be used with a satellite, even one that was designed to be docked with. This universal grappler can still have a purchase to grab on and move it at the end of its life when it's no longer in control and can't, point itself towards us for convenient capture.
Okay, how about orbit change maneuvers? Is it also applies through that same grappler system?
It applies to the same grappler system, but for a very different clientele. So
Okay.
that marketplace is, a rocket launch is not one thing. It is
Hmm.
several things in a rapid sequence. And we have gotten very good actually at the first part. The amount of rockets that fail on launch has dramatically decreased as the space industry has matured. The aspects, though, in space, that still has some complications. We're very good at getting out of the atmosphere and getting to an orbit, but just a low orbit. Going from that low orbit to the desired orbit for a satellite, that is the part that still has more failures than we would like. So, for a satellite that is stuck in that position, you're planning to be at 800 kilometers and you're at 300. Oftentimes, they don't have enough fuel on board to get to 800 because that was never the plan. They were going to be put there and then orbit maintain. KMI can have a spacecraft in orbit ready to go pick up this satellite and carry it to its destined orbit. Even though the satellite is functioning, right? It's not a dead satellite. It's perfectly operational. It can maneuver and communicate and do all of those things. It just lacks the fuel reserves to safely make that long journey on its own. We're able to do that. And especially what I like to mention is that most of our journeys on the other services are from higher orbits down. So this can
Hmm.
actually be offered at a pretty nice price point, because otherwise we're making that journey back up to our other customers unladen and without any payload. So it's a
Okay.
nice kind of synergy of we can support, and it doesn't come at really extra cost to us to achieve that.
Size wise or volume wise of the satellites you are maneuvering, What's the spectrum? Is it are we talking about CubeSats, or how big?
So the nice thing about the end effector is size is not a limiting factor. There's and size specifically in volume and mass. Because our end effector works on a way of mechanical adhesion, we can grab on to an incredibly large surface and hold on
Hmm.
to the side. So we
Okay.
don't need to wrap around our target. So we can go for much larger rocket bodies or go for much smaller CubeSats that we can wrap around. When it comes to mass, there is the limitation that we only have so much fuel on board. So if it is a truly massive object, if it's one of the 8,000 kilogram Russian rocket bodies, that will take multiple of our spacecraft to move it a
Hmm.
significant distance.
Yeah, Delta
But
V.
that's still possible.
Okay. How about active debris removal? When you're talking about debris, what kind of debris are you talking about?
The goal for debris removal is either two cases. The first, like I said, that debris that exists as a specific problem to a specific customer, because that's a strong business case. You
Hmm.
aren't worried about other people, gaining advantage from your expenditure as a satellite operator. You are worried about, I have this problem, I want it solved. Those debris fluctuate. Typically, they're the own operator's derelict satellites. If they have a
Okay.
constellation and some of them died early in constellation, they need to move them so they can fill that slot with a new functional satellite. So
Hmm.
that is one business case, and those are satellites that are about the same size as our spacecraft. So roughly, equal or maybe a little bit larger. The other class are the truly dangerous debris objects. These are objects that have been known on things like the McKnight Top 50 list and other research papers that identify them as critical risk for generating Kessler syndrome. They're in a bad orbit, they cross a lot of paths, and any collision would cause way too much fracturing. We're working right now to try to build a coalition of relevant partners that can afford the higher cost because it's a higher mass object, but still an achievable mission for KMI to go and retrieve those objects and remove them from the environment so they don't pose that continuous risk.
Your REACH prototype, REACH is an acronym for Responsive Engaging Arms for Captive Care and Handling. That prototype is currently now on the International Space Station. Congratulations, first. And it's gathering valuable data. Can you walk us through its objectives and how it's pioneering real world testing for orbital logistics?
Absolutely. So the reach technology has been tested on the ground very thoroughly. We have tested it in vacuum chambers. We've tested it in various heat conditions and temperature conditions. We've tested it under electromagnetic and electrical kind of interference conditions. These are all things that we expect to encounter in space, and being able to test them on the ground and confirm the technology still works has been a great milestone. What was missing was the microgravity interaction. And that's a really hard one because you really can't simulate it on Earth. The closest we can get is the Vomit Comet, the aircraft that does parabolic flight path to give you some time of microgravity. But our experiment and our capture process takes so long that we can't fit it in a single cycle. So we only had the option of getting into space and showing it up there. The nice part about this experiment is we could simulate what we expected to see. We can build the simulations that say turn off gravity, and the computer tries to handle that. But we were really flying in the dark. We're really saying the computer thinks this is how it would work. Is that really how it would work? And so the ISS was a nice test and confirmation with multiple material types of that simulation. And I will say that the results from it are different, which is exciting. As a scientist, first and foremost, any data is great data, but especially data that surprises you. So as we conducted these tests and as the capture dynamics were successful, most of the time, sometimes unsuccessful, but seeing in what way they were successful and unsuccessful allows us to pair it back to our computer simulations and tweak the variables to get a more accurate understanding of how this technology is going to function in space. With that improved simulation, we can now make design iterations on the ground and don't have to fly back to space to retest those designs. We can be quite confident in the computer simulations and the accuracy of how they will perform once they get to space.
Okay, cool. Speaking about surprise, what new and unique insights have you gained from the REACH prototype so far, and how are these insights shaping KMI's future strategies?
So I definitely cannot share all the details about
Of
the
course.
insights as critical company secrets and all that, but I will say the insight I think that was most welcoming was it works. And that
Hmm.
was something that we all knew and all believed in inherently, but getting it up on station, watching the astronauts work with the technology and seeing it function,
Hmm.
that was a moment. That was something surprising. And we looked into it. This experiment, capturing a fully uncontrolled object. The cube we're capturing has no internal control, no internal navigation. It's not supporting us in any way to enable this capture. That kind of setup has only happened 3 times or 2 other times before. And this is the first time a US organization has done this. So this is really something interesting and special. And suddenly KMI, which has been a small company and less funding than some of our competitors, we're suddenly now at that forefront. We're doing a thing that really hasn't been done before, and we're learning from it. So that insight of it works and it functions really kind of changed our mindset from one of we're trying to move as fast as we can to get to where everyone else is, to suddenly realizing we're at the front of the pack and the distance behind us is not extreme. We can stretch that further, but we're not behind in this race, and that was an exciting moment.
Okay. Do you have an anecdote where something that happens in the simulation worked well, and when you put it in an actual real life environment didn't work well, or you had to change it?
Absolutely. And so on the International Space Station, our mission design, we are using the Astrobee robots. These are these cute little flying robots that have little eye lights on the front of them that are able to fly around the Japanese experimentation module and perform, various tests. We've mounted our reach technology to one of them, and it flies and approaches our capture cube to demonstrate how a free floating spacecraft might capture a free floating debris object. When we were doing our testing and performing that maneuver, right, and sending the command, move Astrobee to the target then moved away from us. And that was something we had been worried about, was we were going to try to grab and it was just going to squeeze the cube away from us and shoot it out. And we were seeing that happening. And so this was this moment of, oh no, it's our worst fears. The technology doesn't work. We have to go back to the drawing board. And as we're doing this test, we're redoing it, we're trying different angles, and every time the cube just flies away from us. We're like, oh no. And then the astronaut, Commander Sonny Williams, says to us, hey, I'm getting a breeze. And we're like, what? A breeze? The Astrobee uses fans to move around the station. And we had said the command, move forward to the target. And so
Okay.
it was moving forward. And as it got to that moment of capture, it said, I need to stop. I'm moving too fast. I need to slow down. And the
Hmm.
only way it could do that is by ramping up all of its fans directly towards our capture cube. So that's
Okay.
an example of, you really, like, we put so much thought into this experiment. We sat down over multiple hours thinking of every contingency, and we forgot about the air because we get into this mindset that we're a space company. We're going to be working in
Okay.
vacuum. And for this test, we had to realize that. But it led to an interesting discovery, which
Hmm.
was, imagine it's not air. Imagine it's
Hmm.
some phantom force. Maybe it is the arms
Hmm.
contacting, or it is something else. The heavier our target, the less concern that is. We
Hmm.
were able to fix this in our experiment by taking the capture cube and putting mass inside it and
Hmm.
increasing its inertia. And so this
Okay.
gave us an understanding of, okay, if we're grabbing a very light debris object, something that's like, shrapnel from the surface of a rocket body, we're going to have to approach that in a more careful manner than something that has a lot of mass behind it and isn't going to be pushed around as easily. So it was a funny moment of, haha, we forgot the fans, how funny. But the understanding from it actually is pretty critical.
In a rapid evolving field, how does KMI stay ahead in terms of technology and strategy, especially given the high stakes of space operations?
That's a fantastic question. And I'll be honest, I believe our secret sauce is focus, is that we are keeping our scope entirely contained. We talked about the 3 customers that we are approaching and trying to service, but it's 3 customers with one technology. We're staying highly focused on that. And that's really hard in the aerospace industry because, without a doubt, one of the largest customers is government. And the problem with government is they want things. They want things that don't exist yet. And so you can be having your mission and your technology, and then the government announces, hey, here's a big contract to go after another technology. And it'll be so tantalizing because it's a technology that's close to yours. We're doing capture and they want capture with refueling. That's a small step. We could make that change. And if you do that too much, you end up with this scope creep where suddenly your precise and elegant and agile technology has bloated into a Swiss Army knife. And that's great for the government customer who wants all these capabilities. That's what they're looking for. But as a small startup with limited budget, that can be really dangerous. And so I've quite enjoyed the fact that KMI has not done that, has not expanded our technology to try to match every possible market all at once. We've
Hmm.
stayed laser focused on what can we do right now, what can we do right now really well, and once we succeed in that field, we can expand it to other areas, but not before.
Let's now shift gears to challenges and impact. What are the biggest technical and operational challenges KMI would face in executing services like active debris removal and orbital change maneuvers?
I would say definitely a technical challenge we will face is just the unknown condition of the target. When we're talking a rocket body, it may have been up in space for 35, 45 years. We really don't have a good understanding of what that does to the materials of a space object. It's
Okay.
because it's in space, it does not have a breeze. It does not have, the wind blowing across its surface and creating disturbances. So you have this question of, is that still a rocket body? Is that still one piece? Or will making contact with it suddenly reveal it's far more fragile, it's far more electrostatically charged? Have the conditions of the material drastically changed from the other times that we have gone up and captured an object? All of those previous examples of other competitors' missions or space shuttle missions to capture satellites were all done relatively soon after the satellite was put into orbit. This experiment and what we're doing here will have a much longer timeline. So that's a technical concern that we have to do a lot of testing, but also a lot of preparation without a target. Of we
Okay.
have to say, make our spacecraft resilient to electrostatic shock, even though we don't know what is the scale of the shock we might experience. We have to
Okay.
employ mathematics to try and have just a best guess.
When you say targets, are you talking about cooperative target or non-cooperative target or?
I would say I'm talking about non-cooperative targets, but these are
Mhm.
either debris objects that have been up there for decades, or it may be a recently functional satellite that an operator was running, but they may have been running it for 17, 20 years. So
Mhm.
even that case of an operator satellite that has been quote unquote functioning, it's been functioning, but no one's touched it. No force has impacted it. So we still don't know when we go up and try to grab onto it, is there going to be something in the structure that has shifted? And we do have science. It's not a completely unknown question. We do have a lot of science and theories that say it's still aluminum. Aluminum in space for 40 years is still aluminum. It's still going to have a structure. We're still going to be able to hold on to it. So we're not approaching this expecting that result. But until we do it for the first time, that is an open question and one that we will answer by achieving it.
Okay. Another follow-up question, if I may. Are we talking about targets with momentum, with torque? I think this is going to be a really big undertaking.
It absolutely is. The challenge of docking with any target in space, we are assuming a tumble rate. To assume a target is perfectly stationary and does not tumbling in any way is to wipe out 99% of the market. You have to assume your target is tumbling, has some rotation. That may be the reason the functional satellite is no longer working. That may just be the result of 40 years in space with solar winds pushing on it. So you have to assume a tumble. What is nice about the tumble is that over a long enough time, we expect the forces to stabilize the tumble a little bit. You can have an unstable rotation. You can have a satellite, especially one with two solar panels sticking out, that's just asking for instability in how it rotates. But that instability decays over time. And so
Okay.
you end up with the longer the object has been in space, the longer that has been floating around and being affected by these forces, the more likely that tumble exists in a stable form. So, for example, a rocket body may be tumbling about its long axis.
Hmm.
If that occurs, we have much more reasonable approaches to how we're going to dock with it. Many more ways that we can align with that axis of rotation, spin our craft to rotate, and safely dock. It's going to be those earlier objects, the ones that are more unstable and agnostic, that we're going to have to approach differently. I
Okay.
cannot say as to the exact approach, but it
Of
does
course.
involve a bit of a change from your typical docking procedure. Rather than multiple hours to slowly approach a target in a line, we're doing it in a matter of minutes.
Oh. So active debris removal touches on complex ethical and legal issues. In legal, I am referring to space treaties, etc. How does Kahl-Morris Incorporated navigate the fine line between scientific progress and advancements in technology and putting that technology in space and national security concerns?
Absolutely. The first step is willing partners. That's why going for the customer base that is seeking to remove their own derelict satellites is a great starting point. Show we can do the technology without really upsetting anyone. The person who owns the satellite is the one asking us to move it. So that alleviates a lot of the concerns. As you said, though, there is this ethical problem of there is some very dangerous debris that could absolutely impact the entire world, and we don't have permission to remove it. But if we have the capability to remove it, what is the ethics there? Is it an
Mhm.
ethical responsibility to the laws and the treaties, or an ethical responsibility to the future generations that would benefit from a clean space environment? So there's definitely a challenge there. One aspect to recognize is we are one small startup. So for us to try and answer the question entirely on our own is not only unreasonable, it's also not required. There are national organizations, international organizations. The UN signed the space treaties 50 years ago. They can sign ones again. And it's, in our opinion, the missing piece behind updating of these treaties is the technology to do something. So going up and showing that, hey, it's evolved. You can now go up and grab an object in space. And this is
Mhm.
going to be happening with increasing frequency. That is the impetus to then update the treaties with this knowledge and with this understanding. That's one approach to how we view the problem, but it certainly is not a solved problem and it's not going to be an easy problem, but it is a necessary one.
Speaking about national agencies and international agencies, satellite servicing is a hot topic now. The US Department of Defense, through the DARPA, has its own robotic servicing of geosynchronous satellites, the RSGS program. It is evident that DARPA has picked Northrop Grumman as its commercial partner, but their partnership is still a partnership with a government contractor. Kall Morris Incorporated, on the other hand, is a private company. From that perspective, can you outline the main differences in strategy and innovation between such programs and KMI's initiatives? Are there parallel transfers of information, organic divide of mission objectives, or orbit of operation?
Absolutely. So the this relates back to what I was saying earlier about scope and maintaining scope. In the world of government contracting, the way that the contracts are budgeted is you have your direct costs, the costs involved with doing the contract, and then you have general and administrative slapped on top. The starting point for that is a 48% increase in the US. So something cost $1 million, you're asking for $480,000 to support just the general and admin for the company, but that's only the starting point. Many of these prime contractors ask for more and are awarded more. And that reflects the fact that they don't do just one thing, they do many, many things. And they have the administrative bloat to support that. It's not that the administrative bloat is necessarily a bad thing. They need the administration to run these massive multi-million-dollar corporations. And there's a reason behind all of that. But KMI can fit into a niche that they can't touch. We can be price competitive in our narrow focus. And that is something very special about startups and really an advantage of startups to the whole ecosystem. If startups didn't exist, if we only relied on large established companies to do this work, it would always come at a higher cost. Startups are able to pave the way and carve out a section of the market for us, but that doesn't mean we claim the entire market. It is quite unreasonable, and I don't include this in my financial forecasts, to imagine that KMI is going to own 100% of the debris removal market or the life extension market. But I can imagine that we're going to own 20%. And 20% for us is going to have a much higher margin and a much, further revenue growth model than 20% of the market for Northrop Grumman.
Okay. Adam, China is rapidly advancing in its space capabilities. In 2023, Chinese scientists have already tested a deorbiting sail technology on a space mission. How do you see KMI's approach differing from or potentially aligning with China's state backed programs in space debris removal and on orbit servicing?
Well, first I'll say I am so happy that China is joining the race because they have a third of the debris. So there's absolutely this responsibility from them of they have debris to clean up. So it's fantastic that they are taking that responsibility to actually pay for it themselves and go up and do it. So that aspect is a positive. There's absolutely the concern about national security. There's the concern about this capability in space being used in times of war for activities that we wouldn't. It's a risk that I think the world has to take in a certain sense. Just like the risk of a tow truck to accidentally repo the wrong car, you have to assume that the actors involved are going to use it responsibly, and especially if you can have international treaties around to cordon in the activities, that will help. As far as a company, something about a state sponsored enterprise like that is how it's dependent upon the state that is sponsoring it. So there is an element where the free market aspect of KMI, being able to service multiple customers across multiple countries, that is an advantage that the Chinese company will struggle, but not be impossible for them to overcome. Frankly, it really is a place of competition. China is investing heavily into space, and they do have the capability and the technology to perform quite well. So the real race in this, emerging market, it's with our commercial competitors, but China is a big looming giant that we're going to have to face. Again, though, the target is not 100% market share. There is room for China to evolve its industry to service its debris, and for KMI to exist to service the US debris as well.
Great. Do you see a need for greater regulatory oversight in the space debris arena? And if so, how should that be balanced with the need for innovation?
Absolutely, there should be a greater oversight, and specifically in the area of post mission disposal. So, this concept of you launch something into space, and the beauty of an orbit is that once you get up there, it requires very little energy to stay up there. And if you go high enough, it requires no extra energy. You're just going to be in space for the next millennium. And so, with that capability comes a responsibility that when you're done with your mission, when you're no longer making efficient use of that public good, you stop occupying the space. You stop, polluting that environment and allow the next brilliant mission to take your space. So, having an end of life disposal strategy is an important regulatory requirement, and we currently have that. That is currently the requirement from the FCC and ESA to have this deorbit plan within 5 years of mission end to responsibly remove yourself. The issue is that the only strategy we have right now is self disposal. A satellite will remove itself by removing itself. The issue is any problem occurs during that mission, anything unexpected, now it can't remove itself, and we don't have a backup. So again, this is going to sound, cliche because I'm the company offering the service, but having a third party provider for end of life service provides a resiliency that the industry needs. If I go up to remove a satellite for its end of life and I fail, I
Mhm.
miss the target, I'm not able to grasp it, I spin off into space and have to readjust myself later, I come back and try again. That's not the end of the mission. And let's say
Mhm.
my spacecraft is not recoverable. It's not going to be able to do it again. I can launch another mission, or one of my
Mhm.
competitors can. The resiliency of a servicer is that you are no longer dependent on a sole machine to perform all its functions. So I think
Mhm.
as far as regulation goes, we need to get beyond this idea of personal responsibility ending at the satellite. It is a organizational responsibility with support from outside to accomplish the end goal, which is a clean space environment for future generations and future economics.
Great. On the other side of the spectrum, how do you navigate investor expectations given the high stakes of space operations?
That is certainly a challenge, and it's in fact a quite big challenge. Investors are not strictly that concerned with equipment failure, which is something that as a scientist and as a director of science, I was surprised by. Our first pitch is really focused on the confidence that our equipment is going to work. Now that hasn't changed. We still have a lot of confidence that our equipment is going to work, and that's what the testing on the ISS is all about. But the understanding for the investors is that we're going to focus on that as a space company, as space enthusiasts. That's what we're going to focus on is the equipment. What they are most concerned about is the business case of, yeah, you do something cool, Space is you get the cool by default. When you go into space, like the cool is not a question. You start with a rocket launch and then you're floating in space at 17,000 miles per hour. They understand this is going to be cool, but is anyone paying for it? Is there a revenue base? And more importantly, is that revenue base continuing? If it is just a one-time purchase, that's not a company, that's a research project. And so the toughest part for us has been KMI started with a sole focus on debris removal. And for the first couple of years of our company, that was the only customer base. We went to investors and said, we're going to grab space debris. And that's all there is to the story. And frankly, they were right to brush us off a little bit because that story is not yet starting at the level that it needs to. And it is not starting rapidly enough or reliably enough. As we expand, though, and now we're able to offer life extension, orbit change, and debris removal, that is a diversification that investors now understand. The life extension and orbit change, that is a need today. We have customers speaking to us that need this service as soon as we can launch it. So that provides us the benefit of saying, okay, we can do this now. We can be revenue generating, we can offer a good service, and we can get better at our craft. As ADR becomes a necessary part, and it will, we have to clean up this debris eventually, and that's going to be a massive payday for the companies that are involved. We will show up not as a new contender with unproven technology, but as an established and experienced provider of a reliable service. That is the story that investors now look at and say, I see the future. And now our
Mhm.
challenge is, does that future arrive soon enough?
Great. On that note, how do you see achievements in on-orbit servicing and logistics influencing the broader space economy? Could these innovations spur new industries or markets?
So you're going to get me sounding a bit more like a nerd and less like a space company owner
Please do.
because this is the exciting moment for the space industry. The economics of the last 50 years has been, what data can we retrieve from space? That is the number one question. What data? And it's not just because the data is valuable. The perspective from space is one we've never had before, and the ability to map the Earth every day, that's amazing. But it's because data is cheap to transfer. As opposed
Mhm.
to bringing material down, sending down data, that is a affordable expense for a valuable product. Within space servicing, that starts to shift, and suddenly material product, material value becomes a possibility. Something that KMI has done that I think reflects a larger change for the economy as a whole, we have focused on electric propulsion in our spacecraft. The
Okay.
reason for that is the efficiency. It is a more efficient engine for the environment that we are going to be in. The problem is our spacecraft could never fly out of the atmosphere on its own. It needs to ride a rocket using a different approach to get into space before our approach takes over. That Kármán line is not just a physical line, it is a technology line. If you're underneath it, you need one suite of technologies. But if you're above it, you can use another. And that's where the space economy is moving, is we've been using rockets and the rocket technology above the Kármán line for the last 50 years. We're now starting to shift to say there is space specific technology that is more efficient in space than trying to use a rocket longer.
Mhm.
Building a in-space freighter that does not have to be aerodynamic, that does not have to follow the rules and structure of surviving the 2 minutes of launch, that will achieve an efficiency that we have not yet imagined for the space economy. The joke that I say with my engineers is how we're spending 90% of our effort planning for the first 2 minutes of the mission, because you have to survive the intense moment of rocket launch. And then once you're in space, it's an entirely different environment. Being able to fixate and plan on just that environment will alleviate a lot of inefficiency and increase the value of space for everyone.
Space technologies often find applications in extreme environments here on Earth. Could you share examples where innovations from KMI have been or could be adapted to solve terrestrial challenges?
Absolutely. So the technology of reach, of grabbing an object in space, we need some kind of adhesion, but you're in space. So you can't use suction because you're already in a vacuum, so that won't work. We can't use magnetics because most of our targets are not magnetic. They're not designed to be. And we can't use like a sticky adhesion because any sticky adhesion is going to be somewhat liquid and it'll sublimate in vacuum of space. So without any of those classic approaches to how you stick to something, we were left with a material called gecko
Mhm.
material.
Mhm.
It is this mechanical adhesion, And that same technology, made by a company called Gecko Materials, which I will speak to because they're one of our partners, they are using it on Earth in amazing applications where you need to stick to something without leaving any residue. So the challenge of how do you move the silicone wafers for computer processors from one part of the machine plant to another without leaving any residue. If you grab it and there's a smudge, you've just lost a bunch of efficiency from your machine. So the Gecko material is able to grab on, move, and when it releases, there is no mark left over. It is atomically completely clean. And so that kind of technology and that kind of approach is exciting. It's that same story that we're so familiar with of an innovation in space that has most people on Earth saying, why are we spending money on that? Why are we focused on that? Resulting in an improvement on Earth for everyday people, for every computer, the ones that we're recording this on, becoming more efficient by result of that space tech.
Great. Looking ahead, what trends do you believe will shape the next decade in on-orbit servicing, especially with the integration of advanced robotics, humanoid robots, AI, autonomy, and commercial expansion in space?
I think one of the biggest events in the near future is going to be the decommissioning of the ISS. That event on its own is going to be a spectacle. You're going to see people sailing out in the Pacific Ocean to watch it come in through the atmosphere, the largest object ever put into space. But what it represents is a need to try something again. When we built the ISS, that was an in space assembly project, and it took decades and thousands of spacewalk hours and so much effort and billions of dollars in cost that everyone looked at it and said, wow, I don't want to do that again. The Chinese have been very recent with putting up their own space station, but for the longest time, every country said, wow, we did a lot of effort with that ISS. Let's never do that again. And so we had this kind of stall where no one wanted to do that effort. But a lot of technology has improved. And now with the ISS reaching its end of life, whenever that ends up being, the replacement spacecrafts and space stations are discovering we've gotten better. We've improved our skills. And when the next space station goes up and it has more volume than the space station does, is built in a fraction of the time and for a fraction of the cost, there's going to be many parties that scratch their heads and say, "Hold on, we can have our own space station. Hold on, we can start having a base in space for industrial activities, for agriculture, for medicine." Space is going to no longer be this remote outpost with a single one or two collections of astronauts doing advanced scientific work. It's
Mhm.
going to start to expand. And that is something that I am excited to support as KMI because that brings to us the fourth customer base, which is the in-space logistics. If you launch the supplies for your space station, don't bother putting them directly on your station. Just get them into orbit. We'll come in and grab them and move them where they need to go, and that industry might be bigger than all the other three combined.
Great. What can governments, industries, and even individual entrepreneurs do today to prepare for the evolving landscape of space exploration and commerce?
I would say, I would offer this advice to anyone, not just in the space industry. Think about the things that everyone knows.
Hmm.
Everyone knows space is expensive. Everyone knows space is dangerous. Everyone knows that the ISS is a unique instrument. Anything that everyone knows is 20 years out of date. That's how long it takes an idea to disseminate through the entire population and for everyone to know it. So if you're basing your business strategy off of information that everyone knows, you need to reevaluate and you need to look a little bit deeper. Because what everyone knows is what the entrepreneurs and the innovators are ignoring. Because they're looking at what is actually true today and what can be possible in the future. With that advice, though, I will caution try not to plan for things that have not yet been achieved. I am personally worried for the many, many startups that I have seen that have at the very beginning of their business case, and we will use Starship to achieve this. It's not because I doubt that Starship will work. They've already gotten into space several times. They've had a string of issues recently, but they will get back into space, and that rocket will fly. But the concern is you don't know all the details until the technology exists, and you don't want your business plan to be waiting on someone else to achieve something before you can start. So
Hmm.
don't focus on what everyone knows and don't be held back by that, but also don't rely on a future event which has yet to occur. Look at a very real take on what is possible today and make the best plan you can for that and for the near future.
Adam, that's a great advice. Finally, looking ahead 20 to 30 years, what breakthroughs or trends in the realm of space logistics do you find most exciting? And what might that mean for the future of human presence in space?
So I am personally quite excited for multi-planetary industry.
Hmm.
And that does not mean that we have, mega cities on Mars yet. In 30 to 40 years, I still expect progress to be relatively slow, but I do expect permanent habitation on other planets. Reason
Hmm.
being, the trip is very long. So you don't want to send someone to Mars, have them be on there for 2 weeks and then come back. You want to have a longer established presence. With that comes a need for logistics, comes a need for shipments to Mars. But by means of orbital mechanics and how the planets rotate, we don't get to do this all the time. You can send an emergency supply on a specially built spacecraft and get it there whenever, but most of the time you're waiting for the transfer windows. And so, with that dynamic, you end up in a situation where logistics is not this steady in and out flow of cargo ships like you would see in a harbor on Earth. It is instead this armada of freighters and other vehicles getting ready on both planets. And on the moment when we reach that optimal window, everyone's saying go at the same time. I think in the near future, in the coming decades, there is going to be a celebration every 2.5 years as people go out in their backyard and watch as 100 ships in space turn on their engines at the same time and head off to another planet.
Okay, speaking of other planets, do you think if you got a choice, Mars or one of Jupiter's moons, Europa, Ganymede, Io, where would you go?
If I'm going for the view, definitely one of Jupiter's moons. If I want to survive, definitely Mars. Mars has the problem of, some inconsistencies, but it's basically the most extreme desert on Earth is the conditions of Mars. Jupiter's moons are the most extreme nuclear reactor on Earth. Jupiter sheds a lot of radiation, and any moon, any colonization of a moon around Jupiter would need far more protection than is reasonable right now to achieve. So there's plenty of science fiction that describes walking across the surface of Ganymede and seeing Jupiter, and I hope that that's in my lifetime. But realistically, that might be the end of my lifetime if we're being real about it.
So yeah, speaking of science fiction, do you have a favorite science sci-fi genre, or are you into like science fiction books, movies, anime?
I think my two favorite series, the first one is a little bit more recent and it's called the Bobiverse series. And it's really just very fun for science minded engineers of the story of a man whose brain is put in an AI and he's exploring the universe. So it's a very fun story for just that fantasy of getting to explore the universe in a body that is able to do many things. One that really guided me, though, from very early in childhood was actually Ian M. Banks' Culture series, which is a very fun story about you start with the setting of a futuristic society that spans the galaxy and then tell the stories that can occur there. A post-scarcity society where you don't need to, work for your daily meal, but you still need a purpose. And there are still, issues and diplomacy and crises in the galaxy, and you have to deal with all of them. Both of these stories, I think, kind of hit at what I believe as a person, which is there is more to life than just the next 2 weeks and the next paycheck. There is really this higher goal and this higher pursuit that we can all reach towards. And I think we'll get there as a society and as a humanity. We will get to that exciting future.
Adam, before we wrap up, is there anything else you'd like to share with our audience?
Yes, so would love to just express to if you're listening to this podcast and you've liked the story that I've been telling, please reach out. You can find us at kallmorris.com, Kall spelled with a K. We have a contact page on there as well as on social media everywhere at Kall Morris. That reaching out to us and telling us about your story is something that we are excited about and want to share in. It does not have to be a direct offer of support or a direct way in which we can be engaged, but just tell us about your passion. There's something at KMI where all of our employees and all of the staff have a passion for what we're doing. And I would love to hear about what your passion is for what you're doing to see if there's a way that it can be aligned. Space is not just for the engineers and the mathematician, space is for everyone, and there's a way that we can all help.
Adam, it's been great having you here. I have enjoyed our conversation.
I've enjoyed it as well. This has been a great time.
To everyone else listening, this is the Omar Alayli podcast. Thanks for joining us and keep exploring.